Here again we have a twofer. We've got a lesson on slope and a lesson on equations of lines. A 2-point, the slope y-intercept form. It's not really anything new for you here, I don't think. So we'll be able to move through this pretty rapidly. We're going to be finding the slope of a line when we have 2 points. You know how to do that already. The slopes of horizontal and vertical lines, we know that when we're talking about a horizontal line, we're talking about y equals some number. And when we're talking about a vertical line, we know we're talking about x equals some number. Graph the following lines on the same graph. Well, let's go for it. I'm going to here. Y equals x. Well, we have a intercept right here. True. And what's my slope? It's 1 over 1. So it would be a positive going in this direction. Don't need all these points, but it's so easy to graph. I'm just going to go ahead and mark it. Okay, so that's for this one. Now let's try the next one. I'll do that one in green. And here again we have the y-intercept is at 0. And what's my slope? I'm going to go up 2 over 1. Up 2 over 1. And of course I could go similarly here. What else? So that's this one. Then we'll do the 1/2. Again, what is the slope? The slope is 1/2 and the y-intercept is 0, so we'll start right here. They're all starting in the same place. And we're going to go up 1 over 2. Up 1 over 2. Up 1 over 2. And we can mark it over here as well. So that's for this one. And finally, we'll do y equals negative 2x, and I probably should thicken this line again. Again, we're starting right here at an intercept of 0, and this time we're going to go down 2 over 1. Down 2 over 1. All right, so let's draw the line here for the first one we did. I like to refer to this one as my parent graph because it's the very simplest linear function you could have. The next one is a modification on that parent graph, and is it evident to you what that modification is? The slope is doubled, isn't it? We go up twice as fast as we did with the parent graph. And in this one, what happened to the slope? It's much more shallow. We go up half as fast as we did with the parent graph. And finally, we have a negative slope. It's the only one we did with a negative slope. And on this one, when we move from left to right, we're actually descending. On the other three, as we went from left to right, we were going up. So this is an example of a negative slope. Here's a table of values, and let's take a look at this equation. We have a slope of 2 over 3, and we have a y-intercept of plus 4. So we know when I go to graph this, if I, let's see, x, y, and I'm going to have a scale of 1 by 1 on this grid. So my y-intercept is right here, and my slope, which is up 2 over 3, isn't actually going to work here. So I'm going to think about it as -2, -3. That's equivalent, isn't it? You bet it is. So I'm going to go down 2 and back 3. Down 2 and back 3. I'm actually going off my window here. And you can see where this is going to graph. I'm going to graph right like that. What is the value of y when x is 0? That's right here. It's 4. What is the value of y when x is 3? That would then be 2 plus 4, or 6. What is the value of y when x is 6? That'll be 4 plus 4, or 8. What is the value of y when x is 9? 10. Now, one of the things you might notice is as we go from 0 to 3, we are increasing 3. And as we go from 3 to 6, we are increasing 3. And as we go from 6 to 9, we are increasing 3. So as we increase by the same amount, what happens over here? Maybe I'll change color just to make it. We are going from 4 to 6, that's a plus 2. And then from 6 to 8 is a plus 2. And then from 8 to 10 is also a plus 2. That doesn't look much like a 2, but it is. So the rate of change is constant. Every time I go over 3, I go up 2. This is something you can always look at to understand whether or not you have a linear function. When you have a linear function, you get a constant rate of change. That constant rate of change is expressed as the slope. We see it here, don't we? The change in y, positive 2. The change in x, a positive 3. The points 3, 5, and 7, 11 are on a line. Ooh, well, let's see. I'm going to try graphing those just to help us understand what we're doing here. That'll be 10, that'll be 10. I know we're going to go off the grid a little bit here, but I think we can manage it. So the point 3, 5 would be right about here. Huh? And the point 7, 6, here's 7, 11 is way up here. So I've got a line, that's probably not too accurate, but something like that. And one of the things I notice is I have a positive slope. So I expect to see slope being greater than 0. What is the slope of this line? Well, I know it is rise over run, and I know that rise over run is the change in the vertical over the change in x. Well, what is the change in my vertical? It's 11 minus 5, right? That's the change I'm seeing as I go from 5 to 11. That's going to be 6. At the same time as I go from 5 to 11 and I increase 6, I'm going to be going from 3 to 7. So I'm going to say 7 minus 3, and that's going to be 4. This will simplify to 3 over 2. Now let's see if that plays out here. Go over, well, let's say no. Go up 2, excuse me. Go up 3 and go over 2. Go up 3 and go over 2. There it is. 3, 2. Let's try another one. The points 5, 3, and 2, 8 are on a line. Let's plot them. Okay, here's 5, 3. Remember, my grid is a 2 by 2. And 2, 8. Now, one thing we see about this line immediately is that, unlike when we just did, this one has a negative slope. Here we know that the slope is less than 0. What is the slope of this line? It is the rise over the run. We're going to say 8 minus 3, which is going to be a 5. And we always have to go in the same direction. If I said 8 minus 3, then I have to say 2 minus 5. So a negative 3. So my slope is a negative 5/3. Let's check that out here. That would mean we're going down 5 and then over 3. So minus 5 and a plus 3. Rise over run. What is the difference between a line with no slope and a line with 0 slope? One of the ways we talk about this, no slope, is to say it is undefined. 0 slope means exactly what it says. Well, if you think about rise over run, when would slope be undefined? It would be when run is equal to 0. And run is change in x. Change in x is 0. Well, that happens when you are dealing with a vertical line, right? There's no change in the run. So the undefined is a vertical line. It would be x equal to something. And a line with 0 slope, here you would have a change in the run, but you'd have no change in the rise. This would be this situation. Oh, it would help if let's do it again. This would be this situation where you have a horizontal line. Oh. And it would be expressed as y equals something. Which is less steep, a line with a slope of 10 over 1 or a line with a slope of minus 20 over 1? Less steep. This one is clearly steeper, so the answer is this one. We're not asking whether or not it's negative or positive, just how steep it is. This would be a lot steeper. Is there a limit to how large a slope can be? We might say, is there a limit to how steep a slope is? The answer is no. There is no limit to how large a slope can be. It could be 1 million. Over 1. And then for that matter, it could be a trillion over 1. Now it begins to look, when you've got that kind of a rise and that small a run, it approaches vertical, doesn't it? When you're going up that many units and going over so few. We know when we actually do get to vertical, at that point it's undefined. Find the slope of this line, y equals -1. Well, let's draw it. Y equals -1 would be right here, assuming I've got a 1 by 1 grid. In this case, my rise is 0, right? There's no change as I move across here. And my run is, well, between any 2 points, let's just go between 0 and 1. My rise would be 0 here, and my run would be 1. So my slope for a horizontal line is 0 divided by 1, which is 0. So this is for my horizontal. Now we're going to do slope of this line. And if I graph that on my 1 by 1 grid here, I'm going, and suppose I look at from here to here. In this case, I've got a rise of 1 equals 1, and I've got a run that equals 0. It's not changing for x at all. So I've got m equals 1 over 0, which is undefined. Here's where we say we have no slope. This is a slope equal to 0. This is no slope. And this is for a vertical line. Find the equation of a line with slope 2, m equals 2, and we don't know what the y-intercept is. Well, let's use the slope-intercept form, y equals mx plus b. And that would be y equals 2x plus b. Now look at all the unknowns we have here. What we're really trying to figure out is what this is. And, oh, this is so helpful. Here we've got a value for x and a value for y, which are true in this equation. Let's plug them in. So my y value is going to go there, and my x value here. And when I solve this, I'll know what b is. All right. X goes here, y goes here. So I've got 5 equals 3 times 2. So b equals 5 minus 6, or a -1. So the equation of this line is y equals 2x minus 1. Very nice, isn't it? Find the equation of the line that has an x-intercept, 3, 0, and a slope of 4. Y equals 4x plus b. This time, I'm going to use my x-intercept as a point that I know is true, and I will solve for b. My x is 3, my y is 0, so b is equal to -12. Now I can write the full equation. Y equals 4x minus 12. More with equations of lines. We're going to run right through this. Determine whether the point 2, 7 is on this line. How would we do that? We plug in those point coordinates and see if the equation remains true. So my x goes here, my y over here. 7 equals 6 plus 1. Well, yes, we'd say this is true. So this point is on the line. Find the slope of the line containing the points 4, 2, and 7, 5. Remember what we do for slope. Rise over run. And the rise is the change in y. The run is the change in x between any 2 points. So I'm going to say 5 minus 2 for my change in y. If I went from 5 to minus 2, then I have to go from 7 to minus 4. That's going to be 3 over 3, so my slope is 1. Find the equation of a line with slope 3. So let's write that out. Y equals 3x plus our unknown y-intercept, but we're not worried about finding it because we have a point which is true, which we can plug in. Our x is 2, our y is 5. Wait a second, I just did this one. Did I just do this one? Alright, so y equals 3x minus 1. I guess we've got that example down cold. Find the equation of the line that contains these points. Well, the first thing I'm going to find out is what my slope is. 7 minus 1 will give me 6. 5 minus 3 will give me 2. So my slope is 3. I've got y equals 3x plus b. I don't know what my b is. However, I can use either one of these points to figure out what b is, and I would choose this one because it's smaller numbers. So it's going to be my y, which is 1, equals 3 times my x, which is 3, plus b. So my b is equal to, this is 9. I subtract 9 from both sides, minus 8. My equation is y equals 3x minus 8. What are the equivalent equations for this same line? this one is in the slope-intercept form. There are other ways it could be written. I could be saying y minus y, let's call this x1, y1 minus 1 equals my slope, which I figured out was 3, x minus x1, which I said I would choose that first point. So that's another way this same equation could be written. What else could I do? Oh, I could say a, b, and c are integers and set it up this way. Well, that would mean that I have to 3x minus 8 equals y. I have to make some rearrangement. I just swapped the sides. I'm going to add 8 to both sides. And guess what else? Subtract the y from both sides. So I'll end up with 3x minus 1y equals 8. True, because this will 0 and this will 0. So there we have 3 different ways of writing the very same equation. And you may find in certain situations you prefer one or the other. It depends on what you're trying to do. What form of equation would you find if you wanted to know the y-intercept and the slope? Of course, one of my favorites. What form of equation would you find if you wanted to know the slope of the line and a point that is on the line? Well, why wouldn't we go with this one right here? In that case, find the slope and y-intercept of the line whose equation is y equals 6x plus 9. This couldn't be easier, right? Y equals mx plus b. So my m is right there, and my b is right there. My m equals 6, my b equals 9. Find the slope and y-intercept of the line who has, ooh, well, this one's not quite as simple. We have to make a few adjustments here, don't we? We have to put it into this form. Y, 2y. I'm going to subtract 6x from this side, and I still have plus 24. I'm going to divide everything through by 2, so that'll be y equals negative 3x plus 12. Now that I have it in the slope-intercept form, it becomes obvious what my slope is and what my y-intercept is. Okay, so this is just a quick review of stuff that you learned many years, well, 2 years ago. Maybe even sooner, but 2 years ago anyway. Graphing this one. This one, because of the form it's in, it might be easier to do the intercepts. Okay, when y equals 0, what does x equal? When y is equal to 0, I end up with negative 9x equals negative 3. When y equals 0, this zeroes out. And then I'm going to divide both sides by negative 9, and I end up with x equals a positive 1/3. All right, let's try when x equals 0. When it's in standard form, like, well, this isn't exactly standard form. What's different from standard form? You always lead off with the x in standard form. This one is leading off with the y. But anyway, we can still use the same technique. When x equals 0, What is y going to equal? Well, that would zero this out and I'd have 3y equals negative 3. So my y is equal to negative 1. So I have 2 points now I can use. What are they? There's 0, negative 1. That's my y-intercept. And 1/3, 0. That's my x-intercept. Let me graph them. I'm going to make this 1. Oh, no. I'll make it even easier on myself. I'm going to make this 1 and this 1. So we've got grids which are 1/3 by 1/3. And the reason I'm doing that, I think it's pretty obvious. My first point, x is 0, y is negative 1, so that would be a point right here. Then x is 1/3, and y is 0. And I can graph this, right? Be nice if I could draw a straight line. There it is, something like that. You would draw it straight with a ruler. Find the standard form of this equation. Standard form is ax plus by equals c, where a, b, and c are integers. Good? Well, this isn't an integer, but we know how to clear a fraction. We've been studying that. If I multiply this whole thing by 3, I should be in good shape. So I'm going to distribute to every term both sides. This will make this 15y equals, now 3 times 2/3, I'll end up with 2x plus 3. I'm going to rearrange this. I'm just going to swap sides. I'm still not in the right form, am I? Because see, this needs to be over here and my y needs to be on the other side. I'm very close. I'm going to subtract 15y from both sides. And I'm going to subtract 3 from both sides. So this is what I end up with. I have it in standard form. So there it was, a nice run through some graphing, slope, and linear, why don't we say forms of linear equations. Thanks for hanging in with me on that double session.